In 2016, researchers at UC San Diego published something in JAMA Oncology, one of the most prestigious cancer journals in the world, that I keep coming back to. They followed 2,113 women with early-stage breast cancer for over 7 years. Different ages, different treatment histories, different lifestyles. And when they analyzed the data, one factor stood out above most others as a predictor of who would experience cancer recurrence. Not a drug, not a genetic marker, an eating pattern. Women who fasted fewer than 13 hours overnight had a 36% higher risk of breast cancer coming back compared to women who fasted 13 hours or more. The average participant in that study was 52 years old, 36% from when you stop eating at night. What I'm about to share isn't fringe. It's published in JAMA Oncology, Science Translational Medicine, Cell and Nature Communications. It's funded by the National Cancer Institute. The science on fasting and cancer is being produced by oncologists, immunologists, and molecular biologists at major research centers around the world. The gap isn't between what doctors know and what they're telling you. The gap is between what the emerging research shows and what's been studied long enough and in large enough populations to become a formal clinical recommendation. That's a meaningful distinction, and I want you to understand it before we go any further, because the evidence here is genuinely exciting without needing to be framed as something anybody is hiding from you. Today you're going to understand 5 biological mechanisms through which fasting appears to interfere with cancer development and progression. You're going to see the actual studies, the actual numbers, and the actual limitations of the evidence. And you're going to walk away with a practical protocol, graded by effort and risk, that a person over 50 can begin implementing based on what we currently know. At the end, I'll also tell you exactly where the research is genuinely uncertain, because that matters as much as what we do know. If this kind of deep dive research is useful to you, a subscription helps me keep doing it. No pressure. It just tells me this is worth investigating further. Let's start with the study I mentioned, because I want you to understand it fully before we move to the mechanisms. The JAMA Oncology paper by Marinak and colleagues followed women enrolled in the Women's Healthy Eating and Living study. These were women who had already been diagnosed with early-stage breast cancer, stages 1 through 3, and were being monitored for recurrence. The researchers weren't studying fasting per se. They were analyzing dietary recall data and noticed that nightly fasting duration, the time between the last calorie of the evening and the first calorie of the morning, varied considerably between participants. Some women were finishing dinner at 6 and not eating again until 8 a.m. Others were snacking until 10 or 11 p.m. and eating breakfast at 7. That's a difference of roughly 5 to 6 fasting hours between the two groups. What they found was that fasting fewer than 13 hours was associated with a 36% higher hazard ratio for breast cancer recurrence after adjusting for multiple confounders, including caloric intake, physical activity, alcohol use, and sleep duration. Each 2-hour increase in nightly fasting duration was also associated with lower HbA1c, the 3-month average blood sugar marker, and longer sleep. The association held up in multivariate analysis. Now here's the honest caveat, because this study is compelling but not definitive. It's observational. Nightly fasting duration may be a proxy for a cluster of healthy behaviors. Going to bed earlier, drinking less alcohol in the evenings, having better sleep hygiene. The researchers couldn't prove that fasting itself drove the outcome rather than those correlated behaviors. The finding for recurrence-free survival was statistically significant. The finding for overall survival was not. That matters. It tells us we're likely looking at real biology that influences cancer behavior, but the full picture of what that biology means for long-term mortality is still being worked out. What the study did was open a door, and behind that door a decade of mechanistic and clinical research has been building. The next major thread comes from Walter Longo's lab at USC, and from a randomized controlled trial that I think is among the most interesting dietary intervention studies of the last 10 years. Published in Science Translational Medicine in 2017, the trial enrolled 100 generally healthy adults and randomized them to either 3 cycles of what Longo calls the fasting mimicking diet, 5 days per month of very low-calorie, plant-based, low-protein, high-fat eating, around 800 calories on day 1 and 500 calories on days 2 through 5, or to a normal unrestricted diet as control. 71 participants completed 3 cycles. The results across multiple biomarkers were striking. Body weight dropped, trunk fat and total body fat decreased. Blood pressure fell. Insulin resistance improved by 20% as measured by HOMA-IR. And most relevantly for cancer risk, IGF-1, insulin-like growth factor 1, the primary hormonal driver of cell proliferation, declined significantly. The effect was most pronounced in participants who started with IGF-1 above 225 nanograms per milliliter, which is precisely the population at highest cancer risk. A 2024 secondary analysis of 15 participants from that same trial, published in Nature Communications, went further. Using validated biological age models, including the Grimmage and PhenoAge epigenetic clocks that are now considered among the most reliable predictors of morbidity and mortality, the researchers found that 3 FMD cycles were associated with a 2.5-year reduction in median biological age, independent of weight loss, 2.5 years younger, biologically, from 3 5-day dietary interventions over 3 months. I want to be careful about overstating this finding. The sample was 15 people. The commercial FMD product Prolon is sold by a company in which Longo holds equity, a financial conflict of interest that has to be factored into how we read his research. And biological age clocks, while increasingly validated, are not perfect predictors of individual outcomes. What I can say with confidence is that the direction of these findings is consistent across multiple measurements and multiple studies, and that the mechanisms underlying them are now well enough characterized to understand why this might be happening. The third data point I want to give you before we get into mechanisms comes from a systematic review published in Nutrition Reviews in 2024. Researchers screened nearly 14,000 results and narrowed to 24 studies examining time-restricted eating specifically in cancer patients, people already diagnosed, some of them undergoing active treatment. What they found was high adherence to fasting protocols. Between 67 and 98% of participants in different studies maintained the eating window they'd committed to. That's a meaningful number because if fasting were impossibly difficult for people dealing with cancer, the adherence rates would be low. They weren't. And across the studies that measured cancer-relevant markers, the data showed reduction in carcinoembryonic antigen, a tumor marker, reduced recurrence rates in some populations, and consistent improvements in BMI, blood sugar regulation, and inflammatory markers in as few as 8 weeks. The National Cancer Institute funded 5 intermittent fasting studies in 2020. 4 of them focused specifically on time-restricted eating. The federal agency tasked with cancer research is actively investing in understanding this. That's not a fringe signal. That's a mainstream scientific prioritization. So let's get into what's actually happening in the body, because this is where the story becomes genuinely remarkable. Once I understood the pattern in those studies, I had to understand the mechanism. What is it about fasting that would change cancer behavior? The answer involves 5 interconnected biological processes, and none of them are obvious until you look closely. The first is what I think of as starving the engine. Cancer cells have a characteristic that biologists discovered decades ago, but that's taken a long time to fully appreciate in clinical contexts. In 1924, Otto Warburg documented what is now called the Warburg effect. Cancer cells metabolize glucose at extraordinarily high rates, even in the presence of oxygen, producing energy through glycolysis rather than the more efficient oxidative phosphorylation that normal cells prefer. This means cancer cells are profoundly dependent on a constant supply of glucose. They've essentially rewired their metabolism to demand continuous, high-volume fuel delivery. The problem with that rewiring, and this is what makes fasting so mechanistically interesting, is that it creates inflexibility. Normal cells have what metabolic biologists call metabolic flexibility, the ability to switch fuels depending on availability. When glucose is scarce, normal cells shift to burning fat and producing ketone bodies, which the mitochondria can use efficiently. When glucose returns, they shift back. Your brain, your heart muscle, your liver, all capable of this switch. Cancer cells in most cases have lost that flexibility. The same oncogenic mutations that drive their uncontrolled proliferation, mutations in RAS, PIK3CA, PTEN, also lock them into glycolytic dependence, They can't easily use ketones. They can't downregulate their metabolic rate when the fuel supply drops. So when you fast, when blood glucose and insulin drop, normal cells adapt and thrive. Many cancer cells, particularly those with the most aggressive growth profiles, experience metabolic stress, generate excess reactive oxygen species, accumulate DNA damage, and become more vulnerable to apoptosis, the cell death process they normally evade. Think of it this way. Your healthy cells are hybrid vehicles. They run on gasoline when it's available and switch to battery power when it's not. Cancer cells are old model gas-guzzling engines. They can only run on gasoline, and they need it constantly. Fasting changes the fuel environment. The hybrids adapt. The old engines stall at the pump. This is the first mechanism. But it doesn't work alone. The second process is something most people over 50 have never heard of, despite the fact that it's one of the most important protective mechanisms in the body, and one of the first to decline with age. It's called autophagy. Autophagy, from the Greek for self-eating, is the cellular maintenance program. When cells experience nutrient deprivation or metabolic stress, they activate a process in which they literally digest and recycle their own damaged components. Damaged mitochondria, misfolded proteins, dysfunctional organelles, cellular debris that has accumulated over time. Lysosomes form structures called autophagosomes around this damaged material and break it down into components that can be repurposed for energy or rebuilt into functional proteins. The activation pathway is straightforward in outline, even if the molecular details are complex. Fasting activates AMPK, a cellular energy sensor that fires when the ATP to AMP ratio drops, signaling low energy. Activated AMPK inhibits mTORK1, which is the primary brake on autophagy. With that brake released, a protein complex called ULK1 activates and initiates the autophagic process. The timing matters. In humans, meaningful autophagy induction in metabolically active tissues typically begins around 12 to 16 hours of fasting. Here is what connects this directly to cancer prevention. Precancerous cells, cells that have accumulated DNA damage and early oncogenic mutations but haven't fully transformed, generate abnormal proteins and dysfunctional mitochondria as a consequence of that damage. In cells with intact autophagy, those damaged components get cleared before they can contribute further to cellular dysfunction. Think of autophagy as the building's maintenance crew. Every day they come through, fix what's broken, haul out the debris. The building stays functional. Now picture what happens if the maintenance crew stops showing up. If you go months or years without clearing the accumulating damage, the building deteriorates in ways that compound. After 50, autophagy activity measurably declines. The mechanisms involve age-related reductions in AMPK sensitivity, increases in basal mTORC1 activity from chronic low-grade inflammation, and epigenetic silencing of autophagy-related genes. The result is that cellular maintenance runs less frequently and less efficiently precisely when cells have had the most time to accumulate damage. Fasting reliably restores autophagy signaling. A 2024 review in Aging Research Reviews documented that fasting-induced autophagy was one of the most consistent interventions for reversing age-related declines in cellular maintenance. Animal studies show that stimulating autophagy through fasting or rapamycin extends average lifespan by up to 17%. We don't have equivalent human longevity data. Those studies would take decades, but the mechanistic case is compelling. The third mechanism is stranger and more counterintuitive than either of the first two. Longo's lab named it Differential Stress Resistance, and once you understand it, the implications for both cancer prevention and cancer treatment change considerably. Here is the core idea. When a cell senses nutrient deprivation, it has two possible responses. If the cell's growth-regulating machinery is intact, if the genes that govern cellular behavior are functioning normally, the cell enters a protective low-activity state. It reduces growth signaling, activates stress resistance pathways, decreases its metabolic demands, and becomes more resistant to damage from oxidative stress, chemotherapy, and other cellular insults. Normal cells do this efficiently because the pathway from nutrient sensing to growth suppression, primarily through IGF-1 reduction, PI3K pathway downregulation, and FOXO transcription factor activation, is intact. Cancer cells can't do this. Cells can't do the same oncogenic mutations that drive cancer cell proliferation, activated RAS, constitutively active PI3K, loss of PTEN, keep the growth signaling pathways switched on regardless of nutrient status. The cancer cell gets the fasting signal but cannot properly respond to it. It can't slow down, can't activate protective pathways, can't reduce its metabolic rate. It keeps driving at full speed even as the road narrows. The clinical implication Longo and colleagues have been testing is whether fasting before and during chemotherapy creates a situation where normal tissues are protected by entering the stress-resistant state, while cancer tissues remain fully exposed to drug toxicity. A small pilot study in female cancer patients showed that fasting for 48 hours before chemotherapy was associated with reduction in hematological toxicity, lower drops in white blood cells and platelets. The direct trial in breast cancer, testing 5-day FMD combined with neoadjuvant chemotherapy, found no significant difference in its primary endpoint of side effects. But in a per-protocol analysis, the FMD group showed 4 times higher likelihood of pathological complete response, meaning complete or near-complete disappearance of tumor cells at surgery. That's a striking secondary finding that needs replication in larger trials. I want to be precise about where the evidence sits. The animal data for differential stress resistance is robust. The human data is promising but small. The ACS and MD Anderson currently advise against fasting during active cancer treatment outside clinical trial settings. That guidance exists for good reasons, not because the mechanism isn't biologically plausible, but because we don't yet have the large RCTs to define who benefits, who is harmed, and what the optimal protocols are. For healthy adults using fasting for cancer prevention, which is the primary focus of this video, the risk calculus is very different from using it during active treatment. The fourth mechanism is hormonal, and it involves a number that more people over 50 should know. IGF-1, insulin-like growth factor 1. It's produced primarily by the liver in response to growth hormone signaling and dietary protein intake. Its job is to stimulate cell growth, cell division, and cell survival. It inhibits apoptosis, the programmed cell death that removes damaged or abnormal cells. In the right amounts at the right life stages, IGF-1 is essential. But in chronically elevated states, particularly in adults over 50 who are no longer in growth phases, sustained high IGF-1 has been consistently associated with increased risk of breast cancer, prostate cancer, colorectal cancer, and lung cancer. In 2014, a landmark paper in Cell Metabolism by Levine and colleagues analyzed data from the NHANES 3 study, a nationally representative sample of American adults, and found that high animal protein intake in adults aged 50 to 65 was associated with a 74% increase in cancer mortality and a 4-fold increase in the risk of dying from cancer specifically. The authors identified IGF-1 as the primary mediator of this effect. High protein consumption stimulates IGF-1 production. Elevated IGF-1 promotes cell proliferation and survival across tissues, including cells with early oncogenic mutations that would otherwise die. The same study found that after age 65, the relationship inverted, low protein in that age group was associated with increased mortality. This is a critical nuance for anyone listening. The protein IGF-1 cancer risk relationship appears to be specifically concentrated in the 50 to 65 window. After 65, adequate protein matters more, not less, because sarcopenia, age-related muscle loss, becomes a dominant health risk. What fasting offers is a way to periodically lower IGF-1 and reset that hormonal environment without chronically restricting the protein that aging muscles need. The Longo FMD protocol is specifically designed around this biology. The 5-day cycles are low protein, very low, intentionally, to drive IGF-1 down. The refeeding period between cycles is when protein returns to normal levels to support muscle maintenance. The oscillation between states is the intervention, not permanent restriction. The fifth mechanism is immune system reprogramming. And this is the piece that connects the gut microbiome work we've discussed in other videos with the cancer biology we're discussing today. Your immune system is supposed to function as a continuous surveillance network, identifying cells that have accumulated dangerous mutations and eliminating them before they develop into clinically detectable tumors. This process, called immunosurveillance, is imperfect but consequential. People who are immunocompromised for any reason have dramatically higher cancer rates across virtually every cancer type. After 50, the immune system ages, a process called immunosenescence, and part of what changes is the balance between lymphoid cells and myeloid cells. Lymphoid cells include your T cells and natural killer cells, the active attackers, the ones that identify and kill cancer cells. Myeloid cells include monocytes, macrophages, and dendritic cells, critical for immune function, but in chronic inflammatory states, the myeloid compartment becomes dominated by cells that suppress anti-tumor immune responses rather than promoting them. Chronic low-grade inflammation, which is nearly universal in adults over 50 on Western diets, shifts the immune balance toward this myeloid-dominant, pro-inflammatory, cancer-permissive profile. The 2024 Nature Communications analysis of the Longo FMD trial found that 3 monthly 5-day fasting cycles increased the lymphoid to myeloid ratio, pushing the immune profile back toward a younger, more surveillance-competent state. Separate research from DiBiase and colleagues showed that fasting changes the expression of HO1, a protein called heme oxygenase 1, in opposing directions in normal cells versus cancer cells. In normal cells, fasting increases HO1, making them more resistant to immune attack and to chemotherapy. In cancer cells, it decreases HO1, making them more vulnerable to CD8+ cytotoxic T cells. This differential HO1 modulation is one of the more elegant biological mechanisms I've encountered in this literature, because it creates conditions that simultaneously protect what should be protected and expose what should be eliminated. None of these 5 mechanisms operates independently. They form a system. When you fast, when insulin drops, glucose falls, IGF-1 declines, autophagy activates, the immune balance shifts. You're not doing one thing to cancer. You're changing the entire biochemical environment in which cancer cells must operate. The environment becomes less hospitable for growth. The immune surveillance becomes more capable. The cellular maintenance that prevents the accumulation of damage that leads to transformation becomes more active. Now, here is what to do with all of this. The most important thing I can tell you before giving you a protocol is this. The evidence base for fasting and cancer prevention is at different stages of development depending on what you're asking. The evidence that simple dietary modifications, particularly extending the overnight fast, correlate with reduced cancer recurrence risk is human observational data from a large, well-designed study. The evidence that the fasting-mimicking diet reduces IGF-1, insulin resistance, inflammatory markers, and biological age markers is from a randomized controlled trial. The evidence that these changes reduce cancer initiation risk in healthy adults over long time horizons is mechanistically compelling, but not yet proven in prospective long-term human trials. I want you to hold all 3 levels of certainty simultaneously as you read what follows. Priority 1 is the 13-hour overnight fast. This is what the JAMA Oncology study documented. Finish eating by 7 or 8 in the evening. Don't eat again until 8 or 9 the next morning. That's your floor. It's free. It requires no special foods. It doesn't significantly restrict what you eat, only when. If you currently snack at 10 p.m. and eat breakfast at 7 a.m., you're fasting roughly 9 hours. Getting to 13 means stopping dinner or evening eating about 4 hours earlier. For most people, that means dinner is done by 7 and the kitchen is closed for the night. The reason this matters biologically is that the metabolic switch, the shift from glucose-based to ketone-based metabolism, begins around 12 to 16 hours of fasting in most adults. At 13 hours, you're reaching the threshold where insulin has fallen significantly, liver glycogen is being depleted, and fat mobilization for ketone production is beginning. You're also reaching the window where autophagy induction in metabolically active tissues becomes meaningful. 13 hours isn't deep ketosis. It's not a dramatic metabolic event, but it is reaching the threshold where the biological machinery that connects fasting to cancer-relevant processes begins to activate. The most common failure mode I see with this intervention is the 11 p.m. snack that people don't count as eating. A handful of almonds, a glass of milk, a small bowl of cereal before bed. All of these restart the metabolic clock. Water, black coffee, and plain herbal tea are fine during the fasting window. Priority 2 is moving to 16 hours of fasting daily if your health allows it. This is the standard 16 to 8 time-restricted eating protocol, eating within an 8-hour window, fasting for 16. The metabolic switch happens more fully and more consistently at 16 hours than at 13. Autophagy induction is more robust. IGF-1 suppression during the fasting period is more pronounced. The practical implementation that works best for most people over 50 is skipping breakfast or delaying it significantly and eating from roughly 11 a.m. to 7 p.m. or noon to 8 p.m. This aligns the eating window with normal social meal times while still achieving a 16-hour fast from the previous evening's last meal. Some people prefer an earlier window, 8 a.m. to 4 p.m., particularly if they have an early morning exercise routine. The biology doesn't care which window you choose, only that you maintain a 16-hour fast consistently. An honest note about the evidence here. Most of the TRE studies in cancer patients used various fasting protocols from 12 to 16 hours. The optimal duration for cancer prevention specifically hasn't been established in long-term human trials. What we know is that longer fasting periods activate the mechanisms more completely. What we don't know is whether there's a plateau effect, whether 18 or 20 hours adds meaningfully more benefit than 16 for prevention purposes. Most evidence suggests 16 hours is where you get the substantial mechanistic activation without the difficulty of longer fasts. Priority 3 is the fasting mimicking diet. 5 days per month of very low-calorie plant-based eating. This is the intervention with the most extensive evidence for cancer-relevant biological markers, but it's also the one that requires the most planning and discipline. Let me be specific about what the protocol actually involves. On day 1, you're eating approximately 800 to 1,000 calories. The composition matters: high in healthy fats, olive oil, avocados, a small amount of nuts, very low in protein, very low in sugar, and refined carbohydrates, no animal products, vegetable soup with olive oil, a small amount of olives, herbal teas, water. On days 2 through 5, calories drop to approximately 500 per day, with the same macronutrient composition. Day 6 is the refeeding day. You begin adding food gradually, starting with easily digestible foods before returning to normal eating. A commercially formulated version is available as Prolon. 5 days of prepackaged foods designed to these specific macronutrient ratios Longo's research used. It's expensive but removes the planning burden. The same protocol can be replicated with whole foods if you're willing to track macronutrients carefully. The biological changes documented over 3 monthly cycles include reduction in IGF-1 most pronounced in those who started high, 20% improvement in insulin resistance score, reduction in visceral and liver fat measurable on MRI, improvement in the lymphoid to myeloid ratio toward a younger immune profile, and the 2.5-year reduction in median biological age in the secondary analysis. 3 cycles, 3 months, is the minimum studied in the RCT. Longo's current clinical recommendation for generally healthy adults is 1 cycle every 3 months for maintenance, or monthly cycles for those with elevated metabolic risk factors. I want to say something direct about the protein question, because it affects this protocol specifically, and because the nuance is genuinely important for the 50 to 70 age range. The cell metabolism data showing high protein intake associated with 4-fold increased cancer mortality was in adults 50 to 65. After 65, the relationship inverted. Low protein was associated with higher mortality from multiple causes. What this means practically is that the protein restriction during FMD cycles, the mechanism that drives IGF-1 suppression, needs to be balanced against the protein adequacy during refeeding periods that protects muscle mass. For adults in their 50s and early 60s, the periodic low-protein FMD cycles appear to offer cancer risk reduction benefits. For adults in their late 60s and 70s, the calculus shifts, and ensuring adequate protein intake for muscle preservation becomes more critical. The oscillation between restriction and adequacy, not chronic restriction, is what the evidence supports. Now let me tell you what doesn't have evidence behind it, because this field attracts a substantial amount of noise alongside the signal. Long-term severe caloric restriction, chronic semi-starvation, is not supported by the cancer prevention evidence and creates real risks in older adults, including muscle loss, bone density reduction, nutritional deficiencies, and immune suppression from inadequate protein. The evidence is for periodic cycling, not continuous deprivation. Commercially marketed detox fasting programs that claim cancer benefits have no peer-reviewed evidence base. The mechanisms described in this video operate through specific, well-characterized biological pathways: IGF-1 reduction, autophagy induction, immune remodeling, not through toxin elimination, which isn't a scientifically coherent mechanism. Multi-day water fasts beyond 3 days, outside medical supervision, are not supported by current cancer prevention evidence and carry genuine risks, including cardiac arrhythmia from electrolyte imbalance, refeeding syndrome on return to eating, and orthostatic hypotension. The 5-day FMD protocol keeps calories low but not zero, and the macronutrient composition is specifically designed to minimize these risks. The evidence for prolonged dry fasting, avoiding water as well as food, for any health benefit is essentially non-existent, and the practice is dangerous. Let me give you the timeline of what to expect if you begin implementing this. In the first week to 2 weeks of moving to a 13 to 16-hour eating window, the primary adaptation is hunger signaling. Most people accustomed to eating across a 12 to 14-hour day experience increased hunger in the mid-morning, around what would have been breakfast time, or in the late evening. This is ghrelin adaptation. The hunger hormone is cycling to your habitual meal times and takes 2 to 3 weeks to reset to the new schedule. Power through it. By the end of week 2, the morning hunger typically subsides as ghrelin adapts. Some people experience initial fatigue, mild headache, or difficulty concentrating in the first week. These are common and generally resolve within 7 to 10 days as the body adapts to the metabolic shift. By month 1, if your baseline fasting glucose or HbA1c was elevated, you'll likely see early improvement. The inflammatory marker hsCRP, high-sensitivity C-reactive protein, typically begins declining within 4 to 8 weeks of consistent TRE in people who started with elevated levels. If you do a first FMD cycle in month 1, expect fatigue and headache most prominently on days 2 and 3, the glycogen depletion phase. Most people find days 4 and 5 easier as ketone production ramps up and mental clarity often returns or improves. After 3 FMD cycles, roughly 3 months of monthly practice, the studies show measurable reduction in IGF-1 in those who started elevated, improvement in HOMA-IR, and the changes in body composition toward reduced fat mass with preserved lean mass if protein was adequate during refeeding. The biological age reduction finding was from this 3-cycle mark. The markers you'd want to monitor if you're tracking this seriously: fasting IGF-1, available through standard lab panels; fasting insulin, HOMA-IR calculated from fasting glucose and insulin; hsCRP as an inflammatory marker; and HbA1c, a baseline measurement before starting and repeat measurement after 3 months of consistent practice would give you a meaningful before and after comparison. Before I close, the safety parameters deserve explicit attention. Do not attempt the fasting mimicking diet or extended fasting protocols if you have type 1 diabetes. The risk of hypoglycemia is severe and not manageable without medical supervision. If you have type 2 diabetes managed with insulin or sulfonylureas, drugs including glipizide, glyburide, or glimepiride, the same caution applies. These medications can cause dangerous blood sugar drops during fasting. Metformin-only management is a different situation with lower hypoglycemia risk, but you should still discuss any fasting protocol with your physician before starting. If you are currently undergoing chemotherapy or radiation for any cancer diagnosis, do not add a fasting protocol without your oncologist's explicit knowledge and approval. The evidence for fasting during active treatment is promising, but not yet sufficient for it to be done outside of clinical trial settings or direct medical supervision. If your BMI is below 18.5, if you've had significant unintentional weight loss in recent months, or if you have a history of an eating disorder, these protocols are not appropriate without medical evaluation first. For people on blood pressure medications, fasting can cause additional blood pressure reduction. Monitor carefully. For people on warfarin, dietary changes can affect INR. Monitor as you would with any diet change. For people on lithium, the dehydration risk during fasting can affect lithium levels. This requires extra care with fluid intake and physician awareness. The alarm symptoms that should send you to seek medical evaluation, not continue with fasting, are fainting or near fainting during a fast, significant heart palpitations, inability to eat due to nausea after a fasting period, confusion or disorientation, and any significant unintentional weight loss that isn't from the FMD protocol itself. Unintentional weight loss without deliberate intervention is a symptom requiring evaluation, not a benefit. I want to close by bringing this back to where we started. A 36% difference in cancer recurrence risk from when you stop eating at night. That number has stayed with me because it suggests that the biological environment we're maintaining in our bodies, day after day, through how we eat, when we eat, what fuels we're running on at 2 in the morning, is not static background noise. It's active biology. It's autophagy running or not running. It's IGF-1 elevated or falling. It's immune surveillance sharp or dulled. It's cancer-suppressing gene expression switched on or slowly going quiet. The research on fasting and cancer is not complete. The large prospective RCTs that would conclusively demonstrate that a specific fasting protocol reduces cancer incidence in healthy adults are still being designed and conducted. The NCI funding 5 studies specifically on time-restricted eating and cancer reflects a scientific community that finds this question genuinely compelling and is pursuing it rigorously. What we have now is mechanistic evidence that is strong and consistent, observational evidence in human populations that is striking, and early-phase clinical evidence that is promising but preliminary. That's enough for me to say that the interventions I've described, particularly the simple 13-hour overnight fast as a minimum, extending to 16 hours if tolerated, and considering periodic FMD cycles for those with elevated risk factors, have a serious, credible, peer-reviewed evidence base that I think people over 50 deserve to understand in full, not as a replacement for colonoscopies and mammograms and oncological care, as a complement to it, as part of the biological maintenance that the evidence increasingly suggests makes a difference in whether the cellular changes of aging become clinical cancer or get caught and cleared before they do. You have more influence over this biology than a lot of people have been led to believe. The tools are accessible, the mechanisms are understood well enough to act on thoughtfully, and the research to refine our understanding is continuing. If this video raised questions you want to dig into further, my next video looks at the gut microbiome side of this picture. Specifically how the bacteria we discussed in a previous video interact with the fasting-driven immune remodeling we covered today. They're not separate systems. They're the same system looked at from different angles. Leave your biggest question or takeaway in the comments. I read them all, and they shape what I research next. Keep investigating. I'll see you in the next one. Dr. Becker.